that are single pane windows. So the total window building stock is about 2.4 billion. About 24 million new construction are going in every year. About 29 million are being retrofit every year. So if we just look at the retrofits alone of that 2.4 billion stock, it's going to take us about 82 years, right, to replace that existing stock. And that's not including the fact that 24 million a year are coming in every year. So the retrofit rate for these is, not fast enough, right? We're not going to be replacing these single pane windows or these low performing windows that are in existing stock at our current retrofit rates. So that really needs to ramp up if we're trying to get these existing building stock more energy efficient. Go ahead, next slide, please. Getting a little bit more specific to Virginia market, the closest I could get to kind of granular data on this is a 2020 study from Ducker. So this is 2019 data, 2020 study about what's being sold in the South Atlantic. So South Atlantic minus Florida, so that area that's highlighted there. You can see about 3.7 million new construction windows, 3.4 million replacement are going in. So pretty even split there. Looking at the kind of penetration of the Energy Star product, and this is generally kind of the proxy for a higher performance window when we're talking about windows. Is new construction about 90% are being Energy Star rated, replacements 94%, and so this is pretty good. The average in the U.S. is in the kind of mid to high 80s as far as Energy Star penetration. So overall, this market is doing fairly well, but there is, I guess, a reason for that, and maybe go on to the next slide. We can talk about that. And this is a lot here, but we can focus this down on the codes. And sorry, my slides look like they got a little bit messed up with arrows and whatnot, but hopefully it's still legible. So if we look at the IECC again, which is kind of the residential codes that most of us live by, Virginia has adopted a version of the 2018 IECC now. There's some modifications to that, but not on the Windows side. So the requirements for Windows in Virginia right now is 0.32 U factor, solar heat gain of 0.4. If we look at Energy Star, in version 6 is the current version, that V6 2015 I've highlighted. You can see that U factor is at 0.30, solar heat gain the same at 0.4. So the difference between your code minimum product to the version 6 of Energy Star is a 0.02 U factor. In this, is essentially for a manufacturer, there's no difference in this product. So what we're you're saying by that 90% Energy Star adoption is that it's the product they had to meet, they were making anyway to meet code, and their product really already met the Energy Star requirement. So they're getting this kind of additional branding, really essentially at little to no cost. The big deal here is that's going to be changing. So in version 7 of Energy Star, Windows was just passed a week ago, and it's going to go into effect in 1 year. So the end of October 2023, version 7 that I highlighted over there on the right will be going into effect. And so that is a technology jump as opposed to just a slightly different window. The 0.24 U factor that's required there in the new standards, and I'm highlighting the North Central, of course, because that's where Virginia lies. But that 0.24 U factor is a technology difference, right? So new technologies need to be implemented in the Windows to be able to hit that performance target. So we will see the market changing, whether manufacturers choose to continue to pursue the Energy Star label, or if they decide that it's not worth that additional cost. That's something we don't know yet. And we're going to see how the market responds there. So go ahead to the next slide, please. There's one additional item I wanted to just highlight here, is that there has been a slight change in the map from Energy Star. So version 6, and apologize, that looks fairly blurry, but you can still, I think, make it out, is that Virginia, basically all of Virginia in version 6 was North Central zone. for Energy Star. In version 7, it has changed a little bit. So you can see there's a couple counties that are in the northern zone, and there's a few. I don't know if that's one county or multiple. Sorry, I don't know Virginia very well, but that have moved to the south central zone. So a majority is still north central, but you do have a couple pockets where it's north or south central. So that's something to consider if you're working on projects in those areas, that the Energy Star is actually going to be a little bit different in those particular areas. Go to the next one, please. Somebody noted it's multiple counties. Yeah, thank you. So, one thing just before I kind of finish off on these codes and standards is where are things going, right? You saw there's the movement in the Energy Star space. And what this means is really if we look at the next IECC version, so 2024 IECC, which is currently under consensus committee process, really, that's going to move into that void now created. So it's going to move, at least at the current, what's being proposed, and I think is going to be kind of accepted and finalized, is it's going to move into that Energy Star version 6 levels. So we'll see movement there. And that's something that we typically see here, right? With the Windows area, is that the codes will follow shortly behind Energy Star, and Energy Star has been at that version 6 since 2015. It's been there a long time. They were ready to move as soon as Energy Star was ready to move. But there's a lot more happening, right? So I talked about how Windows are really kind of this low-hanging fruit in the building envelope. And so we're seeing more aggressive targets than Energy Star being proposed and discussed in other areas. So California, Title 24, which often leads the way in the US for standards, they're reviewing their 2025 measures now, looking at higher, higher than the, say, 2024 IECC levels. The 2023 New York stretch codes, they're looking at very aggressive targets. There's levels like passive house levels of window performance being proposed. I don't think they'll be go through at passive house levels of window performance, but the fact that they're being proposed and discussed shows you that there's an appetite for this more aggressive approach on the windows than there has been in the past. And kind of looking at this or examining this, how this is really possible, I guess, is we actually did a little investigation, and we published in ASHRAE Journal last year, this last year, and looked at just the current IECC levels of 2021 and the trade-off between what's now in most of climate zones, so 3 and above, where a continuous insulation requirement is now there. And we just looked at what if you didn't put that continuous insulation and instead put that additional thermal performance into the window, right? We know that the windows are so bad relative to the wall that it could be a more effective place to put that additional thermal insulation is into your windows. And what we found is, a typical house, again, say that has 2,000 square feet of wall, is that you can trade off that 2,000 square feet of R5 continuous insulation and just put in a higher performance window, say, nominally 300 square feet on this kind of typical house, and get equal performance for the building. So now it's kind of this kind of first cost conversation, or not a payback conversation for the windows. Is it cheaper for this builder to put in the continuous insulation, or is it cheaper for them to put in a higher performance window? In the numbers that we've looked at, it's actually often cheaper to put in a higher performance window for a lot of builders to do that. So just, this isn't to say that putting in the window, you should not do the walls, of course. Obviously, ideally, you would do both, but it's just to give you that idea that these relative costs and how low performance windows are right now compared to the rest of the envelope, how easy it is to get to these levels. And really, the codes have been able to justify the cost of the continuous insulation. Windows are at that same cost for the same benefit. So what this means kind of in the future going forward, especially if with Energy Star moving, the incremental cost for these higher performance windows is going to get lower, is that, this is opening up the door for, in the future of codes going to this performance level as well. Go ahead, next slide, please. so if you're interested in this kind of deep dive of achieving Energy Star and the technology needed to achieve Energy Star, I did a few presentations for NFRC, the National Fenestration Rating Council, on this. This gets pretty technical, so I didn't want to dive into it here. But if you are interested, I think these slides are available to you. Feel free to check out these YouTube links. You can really get a deep dive into how manufacturers can hit these performance targets. So go ahead, next slide, please. So for here, I'll kind of do the quick summary version of this, and that's the 0.30 level that's being utilized now. This is your typical often vinyl window with one low E coating, so a solar control low E coating with argon gas fill. The difference now to that 0.24 level, which is Energy Star is moving to, is the addition of a second low E coating. And this is a room side low E, or often called the surface 4 coating low E coating, is being added to the window to do this. So you're adding one more thing that's, it adds some cost to the window, of course. And you'll see more often as well as a kind of higher performance spacers, or warm edge, what they call warm edge spacers being utilized in these products as well. So that's kind of your technology jump there. Go ahead, next one, please. So again, here's a kind of summary of the kind of two technologies really that would be utilized to do that. So that room side low E coating, which I talked about. This is a widely available technology. It's been around for a long time, with multiple suppliers. So the cost right now, and it didn't talk about it much on the last slide, but it is there is a it is a more expensive product than, say, a typical low E coating. Initially, right, with the launch of Energy Star, this might get more expensive with the demand going up, but the coaters, the glass manufacturers are going to invest in broadening these lines. It's going to become more of a mass market product. We anticipate the cost ultimately coming down, the incremental cost for that coming down in the long run. Triple pane windows obviously is another option to get there. And again, a product that's not sold very much in the US. It's only about 2 to 3% of the market share. Although the technology has been around a long time, and there are a lot of products, manufacturers that actually have certified product, they just don't sell them. So if we look at the database from NFRC, manufacturers have, more than 190 manufacturers have more than 400, and this is product lines, and this is just vertical sliders, not to mention all the other product lines that are certified in the US. So the manufacturers are prepared to do this, they just haven't done it at scale right now. And so the incremental costs are quite high. If that market changes, the demand changes, they invest in their technologies to produce these at a higher volume, you'll see those costs come down quite a bit. Next slide, please. One technology that we've talked about for the last few years and we've been working on with different manufacturers is this idea of a thin triple window. And the idea there being that a kind of typical triple pane, you hear a lot of complaints about them being too heavy or too wide, the kind of too expensive type window. In the thin triple is a way of addressing some of those problems. So the idea being is somewhat of a drop-in replacement. The insulating glass unit can go into an existing frame that was designed for double pane. This means it's a low entry cost for window manufacturers. You get double that insulating glass performance with minimal weight increase and things like that. This is still a viable solution, and we're doing some demonstration projects, and there's a few manufacturers that have launched products with this technology, and we expect more in the next few years. There has been some modifications to that. One is that when we started this kind of work, Krypton gas was very cheap and very accessible. In the last few years, that has not been the case anymore. So most gases, the Krypton gas is manufactured in Russia and Ukraine, for an example, right? So that market for that type of solution is very volatile right now, and manufacturers, not surprisingly, are not willing to invest in something that's that volatile. So there has been some modifications to the design, and I won't go into the details all here, but there are solutions and there are manufacturers coming out with products that really kind of more resemble a typical double pane window as far as weight and handling in the product, but they're able to get in the kind of triple level performance into that product. Go ahead, next slide, please. I just wanted to touch on that. I've been focusing on the windows themselves here, but there are a lot of other technologies that allow, especially on the retrofit side, that allow you to get high energy savings out of the windows. So secondary glazings, whether that's on the outside, often called storm windows, most people are familiar with that term, or on the room side, which is kind of window panels or secondary glazing. They're called on existing buildings can give you quite a bit of energy savings at a lower cost, right, than installing a new window. So that's always a very good option, especially in these type of climates like Virginia. But also shading systems, so both interior and exterior shading systems do a very good job, especially if you're concerned about overheating or solar gains. Do a great job of reducing energy use as well. Go ahead, next one, please. And so I know this is a case study talk, and so I'll get quickly into those in the last few minutes I have here. Is that we have been doing a lot of testing of these different technologies that I've spoken about throughout the country. I don't have any specifically in Virginia, but quite a few in kind of similar climates in climate zones 4 and 3, 4, and 5. And looking at these both high performance windows, so that kind of triple pane levels, thin triple windows, but also a lot of shading system testing that we've been doing throughout the country. Here's just a snapshot of what that looks like. Go ahead, next one, please. And focus in on a couple of these just quickly. One here is a multifamily site in Rotterdam, New York. Right, this is, you can see, a new construction building. What we did here is did basically half the units, so 4 apartments here have this typical double pane window that they were going to be installing. And the other half, what they did is they just replaced the insulating glass unit, so utilizing the same frame, put in a triple pane, so our thin triple product within that frame. And basically this gives you a very good side-by-side comparison, and also from the builder side of things, right, to understand if they had noticed any differences or had any different issues with the installations of the product. And we had very good feedback on here. Builder didn't really notice much of a difference. They are noticing definitely significant differences on the inside. So residents, the condensation rating, the index increased quite a bit with the triple product. And so what we see from the residences is less condensation, right? These are multifamily units. They aren't big. They're cooking, right? So you get a lot of moisture load into the spaces. You end up with often getting condensation, and you don't get that with the triples. So they're not having any problems with the condensation there. With the doubles, they still have it. So that's kind of the main comment you hear from the tenants. Go ahead to the next one, please. And here's an example. This is a different one. This is in Helena, Montana, so much colder climate. But just to show you that contrast of the condensation, here's the pre-retrofit to post-retrofit. You can see the window on the top. Not only did they have condensation, they actually had ice buildup. And this is a new double pane. This was a code compliant window in Helena, Montana, that would get ice buildup on the sill. Replacing that with a then triple product, again, the condensation resistance went up significantly. Your dew point temperature, you're not getting condensation at all on these products. Another benefit in this particular case is they were very happy with the sound attenuation of the triple pane. So if when you talk about multifamily housing, right, where it can often be near a busy road, or there's other tenants, people nearby, there's definitely benefits to the sound attenuation that a triple product can give you. In this particular case, it was 10 decibels. Not all are the same. So it depends on the window that's being used, but that can give you an idea of the scale. And one of the, I think, the non-energy benefits of going to a higher performance window. Go ahead to the next one, please. I wanted to include one here as an example of something in a very similar climate to Virginia. So this is a project we're working on in California. So the kind of Central Valley of California and the Northern Valley. This is demonstrating triple pane windows in low-income housing, low-income multifamily housing in California. So this is one of the an example of one of the duplexes that we've retrofit with triple pane windows. We've just started this project. We actually don't have, we're baselining the units right now. So we're doing a year of data collection with the existing windows. And we're about 4 months into that now. After 1 year, we go in and retrofit with triple pane and do another year of data collection with the tenants to get a very good understanding of how this is impacting their space and their usability. With a particular focus to this low-income communities. Go ahead to the next one, please. So this is a simulation of some of the benefits that we see in these products, in particular with these with triple products. And it's something concerned when we're going to this electrification. And that's, a lot of the talk in the energy efficiency right now, especially on the DOE side, but a lot of the states as well is the electrification and what's happening there. Right. And Windows really can have a big impact in that space as far as, when they make their biggest impact on the load is when you need that the most. Right. So I'm highlighting the sections here. These were lab home testing. So this is actual measured data is when you have the biggest savings, right, on the heating season is in the morning or, overnight in the morning. You get that biggest savings, which is when you need that peak heat up in the morning. And on the cooling side, this has a lot to do, somewhat to do with the insulation, but also the solar control level of these windows, that you have a lot lower peak for your cooling, being able to reject that solar gains quite a bit better. So you get the kind of best of both worlds, the morning warm up in the heating season, midday peak in the cooling season, where you're reducing these loads. Go ahead and next one, please. So I wanted to include, so for those of you that are interested, here's some references. I don't need to go through them here again. The slides available to you, but for some of these studies I've talked about, just wanted to have these here to bookmark these if you're interested in diving into this a little bit more detail. The next one. And finally, I think my last slide here is wanted to do a somewhat of a pitch here for our partnership for advanced Windows solutions. So if you're interested in some of this work, you're interested in how do you utilize more efficient Windows, or if you're interested in getting, the utilities in Virginia and others working together on getting higher performance Windows into that market, or programs in place to be able to get that penetration higher. Think about working with us. So at Pause, we launched last year with 50+ partners. This involves manufacturers, a lot of utility groups, and others. We have 3 working groups going on right now. Our utility working group, where we have 24 utility programs already members. We work on, working on how to launch programs, market transformation programs. Within these territories, and it's a great group of folks that are interested in how do we get high performance products into their markets. We also have quite a few different pilot programs going on with some large production builders, including Habitat for Humanity, and a few other production builders that are interested, trying out these higher performance products in their fairly large, right, developments, 100+ home developments that we're getting to start to be involved. So a lot of interest here, especially with these changes to Energy Star, of how we're going to be able to get higher performance Windows into the market. And I think that's, go to the next one, but I think that was all I had. So thank you, everyone.
Thank you, Robert. Now you talked a lot about Energy Star windows, but can you speak, what are some other ways that we can get these high performance windows into multifamily and single family homes?
I mean, other ways, meaning?
Outside of government programs stating you have to have this many Energy Star windows, for example.
Yeah. I mean, so yeah, the products are available, right? So I guess if you want them, you can buy them. That's an easy way to get them into your homes. If you have the power to control that, that's a great way. I guess often maybe then that's what the question is going at, is the kind of how do you justify the costs and things like that. The question is, I showed one example of on the new construction side, that the first cost can be a kind of zero first cost incremental change. We actually did a demonstration with Habitat for Humanity in the Pacific Northwest in Oregon, and they did that exact same thing. So they had a complex, I think it was 12 units, and they were able to show actually a equal cost for switching over to the triple pane. And it made sense for them for, basically a no cost change to do this. We've seen several home builders that have that same aspect. On the retrofit side of things, that's a little bit different, and it's especially when we talk about multifamily, where you have this kind of split incentive, right, where the owner isn't occupying the space often, that can become more difficult. And it's, you have to have understanding someone who's interested in doing that, or looking at alternatives to just pure replacement, which is, does it make sense to put in, say, a secondary window? Does it, economically, if say the base windows are still doing their job, which is, kind of keeping moist water out of the building, or do it, a decent job at air leakage, can we make the window product better without this very, much more expensive measure? So, your storm windows or your secondary glazing, highly insulating shading systems or something like that can be significantly cheaper than a full window replacement.
Thank you. I was thinking I'd gotten my windows replaced about 2 years ago, so you've inspired me to go back and look at the specification sheet, because I have no idea if it was triple pane or double pane. All I said was it has to be energy efficient.
Yeah.
Another question for you here. Like heat pumps and building automation systems, the early models of triple pane windows were expensive. How do you suggest that advocates can convince building owners to give the technology another try now that triple pane has advanced so far past the initial models of triple pane windows?
Yeah. So I'd say it's still, expensive, I guess, is a tough one. I mean, I think everybody thinks anything that's any more expensive than the baseline is too expensive, right? So that's always going to be a somewhat of an issue, because triple pane in general won't always be more expensive, but in the US it will often be. I mean, we do hear cases, actually some groups in Northern Europe that we've met with, that, for them, the window manufacturers, it's more expensive for them to build a double pane because they've set up their mass manufacturing to do triples. And so the non-spec product is a double, so it becomes more expensive. But the fact that triple pane has more material than a double, and the US has such a varied climate, especially with the southern zones, that it will kind of always be a little bit more expensive to do a triple. And so justifying that cost, I think, is, it's looking at, potentially the non-energy benefits, that is often a good way to justify that, and understanding what else you're getting. It's not just, say, the energy savings, it's the acoustic benefits, the condensation resistance benefits, and those areas that can make a much bigger difference, especially if you're selling to, say, a homeowner or someone that's going to be in the space, or say if you're a builder and you're trying to differentiate your product from, say, the next builder's product, is having a more comfortable space is what a lot of people are after. And that's, if you look at the National Association of Realtors and National Association of Home Builders has done, surveys, right, of residents, and that is something that comes up quite often, right, is the comfort of the spaces, and triple pane or higher performance windows really serve that better. So it's kind of the same reason that, you can justify a granite countertop over, something else that really doesn't actually provide you any other benefit other than if you just like it better. it's more comfortable, those sort of things. You can get that conversation with the higher performance windows as well.
Great. Well, thank you for your insight this morning. I know I learned a lot, and I'm going to pass the baton over to Brett Hood, who is taking over the next session. Thank you, Robert.
Yep, thank you.
Thank you so much for your time today, Robert.
Thank you, Joyce. Hello, my name is Brett Hood. I am with Community Housing Partners. And on behalf of Virginia Energy Efficiency Council, I am happy to introduce Betsy Farrell-Garcia and Mackenzie Stagg, who are both assistant research professors with Rural Studios Front Porch Initiative. They're associated with Auburn University Architecture Program. This session is entitled Proof of Concept Approaches to Energy Efficiency. And Betsy and Mackenzie are going to talk about a couple of examples of their approach at designing, developing sustainable, affordable, energy efficient housing for the needs in the rural setting. So with that, I'm happy to hand things over to Betsy.
Great. Thanks so much, Brett. And thanks to the Virginia Energy Efficiency Council for the invitation to share these case studies. I'm here with my colleague, Mackenzie Stagg, and we are both assistant research professors with Auburn University Rural Studio, which is an off-campus design build program of Auburn University's College of Architecture, Design, and Construction. Next slide. And our students move out to West Alabama in either their 3rd or 5th year of study to live in a rural community of 183 people, New Bern, Alabama. Next slide. And to work in teams of 3 to 5 in a 25-mile radius overlapping 3 adjacent counties. Next slide. While there, the students become intimately acquainted with and immersed in rural living, and the remote campus offers them a place to focus away from the distractions of main campus activities like football games. The meta project of Rural Studio is that of sustainable rural living. Next, beginning with housing. The student was founded on the premise that everyone deserves decent, well-designed housing. Next, access to fresh food. Next, reliable infrastructure and education. Next. And while Rural Studio is certainly well known for the more public-facing community projects, next, that our students have designed and built, the studio began its work almost 30 years ago with housing. Our students out in West Alabama have designed and built over 25 housing prototypes in 18 years of study and research specifically focused on housing access and affordability. Over the years, next, we've come to recognize the essential criteria that every house must have. It must be durable, buildable, weatherproof, and secure. But these are just a minimum. Next. We also recognize the aspirational characteristics it should have. It should express a sense of presence and dignity for the homeowner. Next. It should foster and strengthen community. Next. It should contribute to the health and well-being of the occupants as well as those who build it. Next. It should offer a means to age in place with dignity and shelter in place with safety. Next. And it should be well crafted to maintain its value for years to come. We want to invest in the local economy and create local jobs by utilizing site-built construction with local materials and local labor and know-how, thereby strengthening our communities. Next. Over the years, our students began to recognize some of the less obvious barriers to housing access. One of the community projects was a firehouse for the town of New Bern, and while it was the first municipal building constructed in over 100 years, it's significant because the students recognized a pattern and began to tease out the implications. They noted that houses in the community were burning down at an inordinate rate, and it was beginning to affect homeowners' ability to get affordable homeowners insurance. And if you can't get homeowners insurance, you can't get a mortgage. And if you can't get a mortgage, no amount of work to design a house this way or that will ever solve the underlying problem. Working in this methodical way, Rural Studio seeks to identify systemic issues and convene partners to address them through collaboration. Our team began to consider how we could extend the impact of this applied research in housing access and affordability beyond that 25-mile radius service area in West Alabama. Next. We developed Rural Studio's Housing Affordability Technical Assistance Program we call the Front Porch Initiative, a faculty-led initiative where we offer housing products and technical assistance developed over decades of place-based work in West Alabama to housing providers working to deliver homes in their own, often under-resourced communities through their established delivery methods with contractors and volunteers. Next. We view this collaboration between the two teams as a symbiotic relationship of information sharing. Next. The students work to develop products and tailor them to a specific client. Next. At the same time, the Front Porch team works with housing policy stakeholders and a network of regional housing providers to advance equitable access to affordable housing. Next. We then share the information learned, creating a constant feedback loop serving both groups. Each refines the other's efforts, yielding better products and technical assistance. Our goal is to continue to refine our products and communication tools so we can offer this research out to a wider network in the future. Next. The Front Porch Initiative takes 1 and 2 bedroom prototypes designed by student teams at Rural Studio and develops them into a product line of homes. Of the many prototypes developed at Rural Studio, we currently have 5 product line homes. They are 1 and 2 bedroom homes that are small but not tiny. They're designed to be as efficient and durable as possible, meet all conventional code and lending requirements, be titled as real property, and be lived in normally. Next. Over the years, our team has developed an instruction manual, next, that helps our students and partners understand the hows and whys of high-performance home building. Next. As part of our technical assistance program, we've developed a library of materials, next, illustrating the range of variations possible. Next. We understand how to design to a high standard of building performance, next, and can measure the impact different assemblies can have on that performance. Ultimately, we aim to study the relationship between high performance building and affordability, next, and how one can affect the other. Affordable housing often focuses on lowering the initial construction cost to the detriment of building performance. We seek to find the balance point between the upfront cost of improved performance and the back-end performance consequences or benefits. By investing in improved efficiency and durability in a healthier home and the surrounding community, can we lower the homeowner's energy bill and insurance premiums and reduce chronic illness? We began to wonder if we could shift a homeowner's monthly expenses to investment in improved performance. Although it would cost more initially, we hypothesized that a high-performance house would actually cost the homeowner less over time. Next. Moreover, we know the benefits extend beyond the homeowner. Research has shown that energy efficient homes are less likely to go into default. This creates value for lenders. Next. Resilient homes save an average of $4 for every dollar invested. Next. And have a higher resale value. And we know healthy homes, next, influence the occupants in a number of ways, not limited to a reduction in sick days, a benefit to employers, and doctor visits, a benefit to insurance providers. We also know that communities that remain intact are stronger, such as multi-generational kinship networks that offer elder and childcare, as well as shared transportation and food. Next. And many of the principles for one goal overlap those of another. Next. We're currently working with a network of housing providers across the Southeast in climate zones 2, 3, and 4. Front Porch Initiative provides the information, knowledge, and know-how to help our partners make informed decisions regarding both the quantitative and qualitative aspects of building performance so that they can provide energy efficient, resilient, and healthy homes to their clients. Today, Mackenzie and I will share case studies with 2 of our housing provider partners and close with key takeaways we're incorporating into our ongoing work with partners. Next. One of our early partners, Auburn Opelika Habitat for Humanity, is the Habitat affiliate nearest main campus, and they offered us an opportunity to integrate a research project into the design and construction of 2 of their recent homes. This research investigates the relationship between initial construction cost and ongoing operating costs related to energy performance. To minimize variations in built performance, next, we identified 2 lots on a common street and constructed 2 of the same houses, a 900 square foot, 2-bed, 1-bath prototype. Next. They're built to two different energy standards and the same structural resilience standard. We elected to build to the more stringent standard first, then applied our understanding of the FIA standard to construct to the Zero Energy Ready standard, reducing construction costs while maintaining as high a performance as possible. Next. Our students ensured that construction met each standard through a 4-step process of modeling, working through various assemblies computationally, testing the airtightness of the envelope at critical points during construction, verification of final performance through independent third-party raters, and monitoring energy consumption at the circuit level. Next. For 2 years, we monitored the energy required to heat, cool, and ventilate the homes. Next. And tracked the cost of that energy consumption for each house. Next. We focus on the energy needed to condition the interior since it's most directly related to how the house is built. Next. We then identified the added construction cost of building to key building systems needed to meet each standard. Next. And found that the added construction cost to meet the higher standard, taken as a cost increase on a monthly mortgage payment, did not result in similar savings. This proves that we could achieve comparable performance at a much lower cost premium. Next. Finally, the FIA standard requires a small solar array to offset some of the energy use of the home. This FIA's house is unique because it's the first house in Opelika, Alabama to have a bidirectional meter, eliminating the need for costly batteries. The project team petitioned the local power co-op to allow this meter, and the policy changes made it possible for other homeowners in town to install their own solar arrays, contributing to the economic stability of the wider community. Now, Mackenzie will share our second case study.
Thanks, Betsy.
Thanks.
Next slide, please. This second case study that we're going to look at today is with Chipola Area Habitat for Humanity, and specifically a development of 4 homes in Marianna, Alabama. For this project, we integrated learning from the project with Auburn Opelika Habitat for Humanity around efficiency and resilience, and we expanded our research around both workforce and finance. Next, please. Early on in the project, we identified 4 primary objectives. First, to increase opportunities for equitable access to homeownership. Second, increasing the area's housing stock as part of the recovery from Hurricane Michael, which damaged or destroyed a significant portion of the area's housing stock. Third, to build a skilled local workforce trained to both recover from disaster events and to mitigate future shocks. And fourth, build high-performance homes that continue to be an asset for the homeowner. Next, please. We utilized the same model test and verify approach that was developed when working with Auburn Opelika Habitat for Humanity. And this has become an approach that we have used with all of our housing provider partners. Next. The Beyond Code certifications that we chose to pursue on this project were tied to funding opportunities for the housing provider and the financial institutions involved in the project. For example, Chipola Area Habitat was able to receive funding for development when building to a Beyond Code energy standard. And we'll talk more about this later, but energy certification also had benefits for the financing of the home. Chipola Area Habitat for Humanity also received a grant from Habitat International's Habitat Strong program to pursue fortified certification, which is about resistance to storm damage. However, they received this funding after the first of the 2 homes were already under construction, which necessitated rebuilding some small pieces of the project. And if at all possible, we would suggest that it's best to set expectations about certifications in the design phase of the project. However, just as a side note, since Florida has some of the strongest building codes around kind of wind resilience, the modifications were not as strong as they would have been in another state, and that was part of what made them possible. So lastly, this was the first time that our team had utilized the Florida Green Building Coalition's Green Home programs. And like LEED, this is a points-based program. And what we found particularly interesting about this standard, which is a statewide program, is that it accounts for both energy efficiency and resiliency in the points. Next, please. One of the new aspects of this project was the integration of a workforce development program. And students from the nearby Chipola College's Building Construction Technology program were integral to the construction of the homes. Next, please. The students would normally perform their hands-on training work in the lab on their campus, where they would earn clock hour credits towards the completion of nationally recognized construction certifications. However, with an agreement put in place between Chipola Area Habitat and Chipola College, this allowed the students to earn these clock hour credits while working on site on the Habitat for Humanity houses. This also allowed them to interface with local tradespeople and subcontractors who would potentially become their future employers. Next, please. This relationship came at a crucial time for Chipola Area Habitat. The Chipola students came on board just as the pandemic was limiting the out-of-town volunteers that had traditionally helped build the homes. Chipola Area Habitat, in turn, was able to provide all of the materials and resources necessary to construct the homes, which meant that Chipola College had more resources that they could dedicate towards program instead of the purchasing of materials. And not only were the students learning to build the homes, they were learning to build energy efficient, resilient homes. And this partnership is growing that skilled workforce trained to both recover from shocks and build back better to mitigate future events. Our contribution was to provide, the prototypes, homes, and the technical assistance needed to build these high performance homes. Next, please. Another aspect of this project was taking a deeper dive into the capital stack of the project to understand how these homes, to build these homes in a manner that made them affordable both to purchase and to operate. So one of the biggest breakthroughs in the project came in the ability to value the sweat equity that was put into the house by the homeowner, the volunteers, and the students, and utilize that as a down payment in the home. Now, my background is in architecture, it's not in finance, but I'm going to try to illustrate kind of high level how this process works. Next, please. So first, that's a little bit messed up. Sorry about that. So first, the borrower or the partner family works with the Habitat affiliate to complete their sweat equity hours towards the completion of a home. And Chipola Area Habitat worked with their partner families to track and value those sweat equity hours. Trying next, I'm not sure. Yeah, sorry, some of these, can you just go, sorry, maybe 3 more slides down? I think, yeah, there we can see it fully. So this, it was supposed to walk piece by piece, but we'll just kind of look at it all on one screen here. So, the Chipola Habitat, they kind of work to help prepare their families for home ownership. And when they were working through the kind of financial pieces with the homeowner, it was determined, that this partner family could qualify for conventional lending. So Chipola Habitat introduced the family to a local lender, which was Regions Bank in this case, to originate the mortgage. And by using the Home Ready product by Fannie Mae and the sweat equity flexibility that's part of that, Regions was able to originate the mortgage on the home for approximately $68,000. The sales price of the home was $140,000. So there's a significant amount of down payment going through there. So traditionally, the Habitat affiliate would have originated and hold the mortgage in their portfolio, which can limit the funds that they have available to develop more homes. But since the mortgage was originated by a primary lender, the Habitat affiliate got that money back at the time of sale, which they can immediately put back into development of the next home. And since Regions, the lender in this case, followed Fannie Mae's Home Ready guidelines, they were then able to sell the loan to Fannie Mae, who is the loan holder, which means that they in turn received funding to originate another loan in their community. Next, please. Sorry, try one more. Yep, there we go. And so, we believe this process benefits each of the parties involved. So through the value of the sweat equity put into the house, the borrower can afford to purchase a high performance home. The housing provider has more access to capital to develop more homes because the mortgage was originated by a lender. The lender then also has the capital to originate more loans because they have then sold that loan to the loan holder. They also, as a side note, received CRA or Community Reinvestment Act credit for originating this affordable loan. And then the loan holder, they received duty to serve credit for purchasing this loan. And to circle back to the energy efficiency aspects of it, because the home was certified to Energy Star, that loan immediately became part of their green bond program. Next, please. So, that's a lot for these 4 small houses to do. And I'm going to try to wrap up today with a few actionable lessons to take away from this presentation. Next. Specifically, when it comes to implementing energy efficiency, the first thing we've found is that it's crucial to set expectations at the outset of the project. And, an energy model and manual J calculations are great tools to use to calibrate performance objectives. Next. And as Betsy showed earlier, it's also a great tool to identify which components and assemblies are most impactful in decreasing predicted energy use. For example, if here, in this case, the manual J shows that the walls are a large component of the heating and cooling loads, then increasing insulation may be a more effective strategy than purchasing higher performance windows. However, that's not always the case, as our last speaker was alluding to, relative to high performance windows. So these kinds of models that are specific to a location can really help develop a response that's most appropriate to that house. Next, please. Second, once you determine which certifications you're pursuing, it's good to ensure you understand both the installation and the evaluation process for those certifications. Next, please. So as an example, one of the Energy Star requirements is that an HVAC, a certified HVAC installer, install the HVAC in the home. And in rural areas and with areas with less demand for these Beyond Code certifications, those installers can be hard to come by or travel from long distances, both of which tend to increase the cost. However, with the size of these homes and with their with the kind of high performance envelope that was used in them, we were able to utilize a ductless mini split system for the heating and cooling of the home. And because that's a packaged system and does not require the balancing and testing of ductwork, we were able to have the local HVAC installer install that system without needing the Energy Star certification requirements. So to kind of understand how these systems influence that, those Beyond Code certifications can save money and resources on the homes. Next, please. The third thing that we have found is that it's crucial to test and course correct throughout the construction process. For example, we found that blower door tools are excellent to use throughout the construction process to keep the home, make sure the homes are well sealed and well insulated. Next, please. So, for example, we didn't talk about this project today, but this is another set of 4 homes that were built in Nashville, Tennessee. And we ran a blower door test after the insulation was installed, but before the drywall went in. And while the initial numbers for that came back much higher than we desired, lower is better in this case, running the blower door test allowed us to identify where the deficiencies in air sealing were and to correct those. So when we ran the same blower door tests on the same houses 3 days later, we received significantly better results. And this is not necessarily changing to a fancier system or a better assembly. This is just making sure that we're air sealing. So it's, a tube of caulk and a couple of hours of labor to get these results. Okay, one more slide, please. And lastly, because we think we might have some policymakers in the room today, we just wanted to reiterate that there are a number of tools and programs which can help incentivize the development of high performance homes. So, this here, and I'm not going to read them all, but it's kind of a list of some of the things that we have seen that have been effective for our partners in different areas. So, first and foremost, it's the adoption of the current building codes. We once heard Sam Rashkin from Department of Energy say that the worst house that you can legally build is one that meets the current building code. So if you're using an outdated code, that's putting you even further behind. There are also funding incentives, be they kind of housing assistance programs that are state or regional level. Utilities have a lot of tools and many great programs that are working on retrofit programs, as well as how Betsy mentioned, incentivizing the use of renewables with things like bidirectional meters are really key to keeping these energy efficient homes affordable. So next slide, please. So as was mentioned by the last speaker as well, ultimately the reason we're advocating for these high performance homes comes down to people. And we believe that these high performance homes are more comfortable, safer, healthier, and provide more economic stability. And we also believe that these homes are better investments for the insurer, the lender, and most importantly, the homeowner. So thank you guys very much for your time and attention today, and we look forward to any questions you might have.
Well, Betsy and Mackenzie, thank you very much. That was a wonderful presentation. And please allow me to say that's really incredible work that you're doing. That's great. Thank you. We have about 10 minutes for questions. If anyone has any questions, please feel free to unmute yourself. Also, feel free to put your question in the chat box. But if I may ask, so after these two projects and other projects, have you changed or evolved your approach in either the design or the energy modeling or the energy tracking that you're doing? You know, what lessons learned have you gleaned from these projects?
So we have expanded our research. We've actually added to the Auburn Opelika habitat study. We've added a third house. It's a code-built house that the affiliate builds typically. And we requested permission from the homeowner to monitor their energy use, much like we monitored the first two houses. And we have recognized through that process that while we were focusing on the energy required to condition the interior space that we can control with the envelope design, we've learned to recognize that there are other pieces of equipment in the building that perhaps are bigger energy hogs. In this case, both of the houses that we presented have heat pump water heaters. And the code-built house, as the affiliate typically delivers, has a conventional water heater. And although we haven't tracked water consumption, we have noticed that in energy consumption strictly, the code-built house is using about $40 per month more. When we compare that to the energy use of the interior space conditioning, it's like $6.50 between the FIAS house and Zero Energy Ready house. So from $6.50 to $40 is pretty significant. We're also recognizing that plug loads are a huge piece of the pie. And when plug loads exceed the energy consumed to condition the interior space, we really need to focus on homeowner education as part of our research. So we're continuing to develop the energy monitoring research. We're partnering with Habitat for Humanity International on a grant program that they're working with Whirlpool on to monitor 16 houses, as well as review the energy bills of 269 homes. So we're continuing to expand this research and hope to continue to publish so that it's helpful to other people.
Well, thank you. In the presentation, you said that I think it was 4 or 5 different designs that you have right now that are all 1 or 2 bedroom houses. Why is the focus on 1 or 2 bedrooms? Or I assume that they're all like 1,000 square feet or less.
Yeah, so that's actually the need that we're seeing in West Alabama in our service area that the Rural Studio is serving. And our clients there are typically older, typically single folks or couples. And in the case of the Auburn Opelika Habitat project, that smaller house was specifically requested by those clients. They did not want a larger 3 or 4 bedroom home that the affiliate typically delivers, and they requested a 2-bedroom house. Moreover, we found that it's harder to build a high performance house when you reduce that interior volume. You know, your surface area to interior volume ratio gets skewed to the point where we had to use a beta version of WWOOFY when we were modeling that pair of houses, because it's just that much harder to get high performance results out of a smaller house.
With the focus on rural, oh wait, hold on. There's a question in the chat. Let me ask that. CHP is doing very similar work. Are you seeing similar results in economics here in Virginia? What lessons do you draw for increasing uptake of these high performance strategies in Virginia? So, Andrew, my work is with the weatherization side. So we are focused on retrofits as opposed to design builds, from the beginning. But in terms of results in energy savings and economics, it's there's so many examples across the board. There's definitely benefits to the energy efficient work that we're doing. But if I can ask Betsy and Mackenzie, again, with the rural housing focus that you're specializing in, would you say, well, what would you say are either the challenges or the opportunities to working with that specific housing stock?
Yeah, thank you for that question. I think that, in rural areas, you tend to find an older housing stock. And so a lot of what we work on with our partners is, and a lot of what we do on the ground in West Alabama isn't necessarily, it's kind of a lot of the housing stock is kind of beyond repair. It's kind of, you can sink some money into retrofitting it and you still have a substandard house. And so we think of what we do there as replacement housing. So we're kind of harnessing a lot of the infrastructure that's already on the site, be it a septic system, because it's a rural area, water and electrical hookups, driveways, that sort of thing. And it's also in West Alabama, we see that a lot of families live in kind of an intergenerational network. And so it might be 4 houses in one area that has an extended family on it. And there's some resilience in that kind of sharing of resources amongst that family. So it's important to keep people in place. So, we think of replacement is kind of an interesting third space that's a little bit maybe more of a rural condition because of the age of the housing stock out there. I think that what we have found working with our external partners, specifically, going back to that project with Chipola Area Habitat and Chipola College, is that rural areas are small and tend to have few resources, but everybody tends to know each other. And so there's a sense of working together and finding creative solutions to outcomes. So this, pairing of a Habitat affiliate that relies on external volunteers with a local college, where everybody benefits from that. I think, that's kind of a particularly rural approach, everyone kind of working in the same direction there. I think relative to performance specifically, I think, there are some challenges around accessing the materials to build high performance homes and systems. But I think one of the things that we've had success in doing is kind of utilizing readily available materials and talking more about the kind of means and methods of putting those houses together. So, those are the things that we learn in those rural places really have, we know that they can be done other places if you can do them there. So.
Well, again, thank you very much. And we are at the end of our time. So I would like to hand it back to our host.
Thank you both so much, and Robert and Joyce as well. This was really educational. I feel like you just did a wonderful job. And actually, personally, I have family in Alabama and several Auburn graduates that I'm related to. So it's just personally really interesting to hear what you're doing. The breakout rooms are closing now. So
Good afternoon, everyone. Thank you to our panelists for sharing their enchanting knowledge with us. I also want to thank our sponsors again, as well as my beautiful staff for pulling together great programming for us today. Be sure to join us tomorrow in person at the University of Richmond Jepson Alumni Center beginning at 1:30. I hope everyone has a hauntingly fun evening of tricks and treats, and we will see you tomorrow. Bye.